Hello teachers, learners, and parents. Sir Jeff po, at your service. Alam nyo ba na meron tayong website na tinatawag na DepEd Commons? Ang DepEd Commons ay binuo upang gawing accessible ang pagtuturo at pag-aaral dito sa ating bansa gamit lamang ang inyong mga smart devices gaya ng cellphones, tablets, at computers. Dito ay maaari nating ma-access ang iba't ibang learning materials mula sa Department of Education. Meron itong mga interactive materials, electronic self-learning modules, at instructional video lessons mula sa DepEd TV na tiyak na makatutulong sa pag-aaral ng mga mag-aaral galing ka man sa public o private school. Walang problema dahil welcome ang lahat dito. Para ito sa mga guro, magulang at mga mag-aaral mula sa kinder hanggang grade 12, alternative learning system o ALS, at pati na rin ang special education. At huwag kang mag-alala dahil kahit walang load ay maaari mong ma-access ang mga learning materials. Tama, libre ito. Ang kailangan mo lamang gawin ay i-on ang iyong data at buksan lamang ang iyong browser at i-type ang commons.deped.gov.ph. Alam na ba ng iyong mga kasamahang guro o mag-aral ang tungkol sa DepEd Commons? I-share mo na ang video na ito upang matuto rin sila kung paano gagamitin ang DepEd Commons sa mabilis at napakadaling paraan. Muli, ito po si Sir Jeff at kita-kits po tayo sa DepEd Commons. Paalam!
Magandang araw! Sir Wilbur po, at your service. Narito ang ETUlay upang gabayan ka sa inyong pag-aaral upang lubos na maunawaan ang iba't ibang paksa o subject. Ang ETUlay ay isang free online tutorial class na pinangungunahan ng ICT's Educational Technology Unit sa pamumuno ni Undersecretary Elaine Del B. Pascua. Ang programang ito ay hindi lamang para sa mga bata, kundi ito rin ay magsisilbing gabay sa mga magulang at mga guro kung paano nila ituturo o gagabayan sa bawat asignatura ang kanilang mga anak o mga estudyante. Sa kasalukuyan, ang self-learning module mula sa rehiyon ng Calabarzon at kilala sa tawag na pivot ang ginagamit sa ating ETUlay online class. Kaya ano pang hinihintay ninyo? Ihanda na ang inyong mga ballpen o lapis, papel o kwaderno at samahan kaming itulay ang pagkatuto para sa bawat batang Pilipino. Sama-sama tayong magtutulungan para malampasan ang mga hamon sa panahong ito. Halina't matuto kasama ang inyong online tutor sa oras na ito.
Happy ETUlay Monday afternoon again, mga senior high school students who are attending our free online tutorial from DepEd Edtech Unit. So we are now on week 2 of quarter 4. If you want to watch again our online tutorial for week 1 of quarter 4, you may revisit the Facebook page of DepEd Edtech Unit, DepEd Philippines, and DepEd Tayo. And also sa YouTube channel ng DepEd Edtech Unit, DepEd TV. So katulad ng lagi nating ginagawa to start our online tutorial, so we remind each other how to have a positive mindset. Ito yun naman yung another tip ko. Kapag ang issue ay about other people, for us to have positive mindset, you may choose not to think about it kasi you are not in control of other people. But if the issue is about you, you are in control of yourself. So doon ikaw may karapatang mag-decide, baguhin yung nararamdaman mo or mag-decide kung ano bang iisipin mo, positive or negative. Since that is for you, syempre you will choose positivity. So again, i-remind ko lang yung mga estudyante natin na if the issue is about other people, you are not in control of them. But you are in control of yourself, so you can decide for yourself, you can change yourself and choose positivity for you. So again, ang magbe-benefit niya na hindi lang kayo, pati rin ibang tao kasi it will radiate. So shout out po sa tutor din po ng DepEd Edtech Unit, kay Yani Marquez, kay Ate Ces Teruñez, kay Marjorie Nariz, kay Gilbert, at sa marami pa pong iba na tumutulong para sa katuparan ng pagtulong na ito sa ating mga estudyante. So for this afternoon, the most essential learning competency that we are going to talk about are the following. So we have use gives free energy to determine the direction of a reaction. Also, explain chemical equilibrium in terms of the reaction rates of the forward and reverse reaction. And then state the Le-Chatelier's principle and apply it qualitatively to describe the effect of changes in pressure, concentration, and temperature. So bago ako magsimula dyan, so nandito ang ating mga estudyante na very consistent, very participative. So nabasa ko na kagad sina John Bryce at nagtatag sila ng madami pa. So ang pinakauna nag-comment dito ay si Jennifer Tampos. Good afternoon. Watching from New Canaan, Label 1 District Division of Sarangani. I know nakapag-participate na din ito last time. So sina Irish, si Marife, si Shania, Trisha, Charlemagne Masiglat, Trisha, ayan. Titingnan pa natin iba. Robert Padsing, Haifa Kosain. So ayan. So good afternoon everyone. We are now on week 2 of quarter 4. Okay, nandito na ako sa laptop ang ipe-press. The first most essential learning competency that we're going to discuss is the use of gives free energy to determine the direction of the reaction. Okay, so dito sa gives free, actually this topic, this learning competency ay para kasama dapat to nung week 1 natin. Pero isinama ko siya ngayon kasi I know this is very important na ituro sa inyo kasi na-discuss natin yung enthalpy, yung entropy, and the reason why we discuss that because we will use that in Gibbs free energy. So hindi ko pwedeng lagpasan lang to. So isinama ko siya ngayon and then idudugtong ko yung lesson for this week. So like what I said, ang Gibbs free, mangangailangan siya ng entropy at saka ng enthalpy. So it can be calculated from the table of standard values. Dito natin kinukuha, di ba, yung pag-compute natin ng entropy. So yung entropy, topic natin yan last week. Yung enthalpy, topic natin yan nung week 5 of quarter 3. So week 5 yon. So the reason why we discuss that, kasi kailangan natin yan for this Gibbs free energy. The Gibbs free energy has a symbol of G. This is another thermodynamic property that is used to predict whether the reaction or process will be spontaneous or non-spontaneous. Gibbs free energy is defined as, ang symbol niya G is equal to the H. Remember, yung H natin ay enthalpy minus the temperature, constant yung temperature, and then yung S natin ay entropy. The change in free energy or yung symbol niya ay delta G of a system for a constant temperature process. So when we say constant temperature process, kung ano yung temperature binigay, hindi yung change in temperature, which is the constant temperature. So the formula is delta G is equal to delta H minus the given temperature times the entropy, change in entropy or delta S. So ayan po ang ating formula for Gibbs free energy. Delta G is equal to delta H minus the constant temperature times the change in entropy. Here are the conditions for spontaneity and equilibrium at constant temperature and pressure in terms of delta G. So ang delta G natin, ito daw yung para ma-analyze natin, yung makukompute natin later, ito daw ang conditions. Kapag ang delta G ay less than 0, the reaction is spontaneous in the forward direction. Spontaneous siya in the forward direction. But if the delta G is greater than 0, the reaction is non-spontaneous. At kapag sinabi naman nating non-spontaneous, the reaction is spontaneous in the opposite direction or backward direction. Dahil ang pag-uusapan natin ay equilibrium, it is in reversible reaction. Okay, kapag sinabi nating ang delta G ay equal to 0, the system is at equilibrium. Katulad ng sinabi ko kanina, it is in reversible reaction, meaning that the arrow that we're going to use is in reversible. Kapag sinabi natin in the forward direction, if the delta G is less than 0, forward direction, so towards the product. Ito naman, towards the reactant. Okay. Let us take a look at this example. Calcium oxide, also called quicklime, is an... Wait, change ko pala yung highlighter muna. Okay, again. Calcium oxide, or CaO, also called quicklime, is an extremely valuable inorganic substance used in steelmaking, production of calcium metal, the paper industry, water treatment, and pollution control. It is prepared by decomposing limestone or yung calcium carbonate, CaCO3, in a kiln at a high temperature. Sulat natin dito ang chemical equation nito. So we have CaCO3 daw. CaCO3. Solid calcium carbonate has a reversible reaction with calcium oxide, solid, plus carbon dioxide in gas form. Tulad ng lagi ko sinasabi sa inyo sa thermodynamics, it is important that we indicate the state of the substance. So in this case, we have solid for calcium carbonate, solid for calcium oxide, and gas for CO2 or carbon dioxide. Okay, in this chemical reaction, the reaction is reversible and calcium oxide readily combines with CO2 to form calcium carbonate. Reversible siya. When calcium carbonate is decomposed, it will form calcium oxide and carbon dioxide gas. And also this calcium oxide, it readily combines with carbon dioxide to form calcium carbonate. So reversible reaction siya. Okay, so I will just put the equation on the upper right side of our screen for us to be reminded of the equation. Okay, the first thing that we're going to do, so mamaya na ako magbabasa ng inyong mga comment, listen muna tayo. Okay, so the first thing that we're going to do is calculate the delta H and the delta S for the reaction at 25 degrees Celsius. So di ba na-discuss na natin last week yung enthalpy nung week 5, then ito na-discuss na natin nung week 1 ng quarter 4 last week lang, and kasi needed yan for the Gibbs free. So since may given dito na 25 degrees Celsius, we have to convert that to Kelvin. Okay? Bakit natin kailangan ng Kelvin? Kasi sa entropy po, ang unit ng temperature doon ay Kelvin. Kapag yan naka-Celsius, hindi natin siya makakancel. So, kailangan natin siyang i-convert sa Kelvin. And for us to do that, we have to add 273 with that 25 degrees Celsius. So, 273 plus 25 is, ayan, 298 Kelvin. Kinonvert ko na kagad, nilagay ko na kagad dyan para mamaya ay magamit na natin. O, hindi ko na ipapasolve pa sa inyo. So, nung week 5 ng quarter 3, tinuro ko sa inyo ang enthalpy. And we know that that is the equation. So, yung nakikita nyo dito, we have CaO. CaO is part of the product. CO2, part of the product. So, di ba, ayan, CaO and CO2. Kasi product minus the reactant. This is CaCO3, this is our reactant. Okay. Para hindi tayo medyo matagal, kasi paghahanapin ko pa kayo ng thermodynamic value or data, binigay ko na dyan. Kayo na lang mag-solve later. So, we have negative 635.6 kilojoule per mole plus negative 393.5 kilojoule per mole minus negative 1,206.9 kilojoule per mole paki-press nga po sa kindly type in your answer in the comment section. So I provided the thermodynamic data. I have put that in the formula. You just need to type in that in your calculator. So pag na-solve nyo na, paki-type in po sa ating comment section and I will show to you if your answer is correct. So while waiting, ito magbabasa ako ng pero syempre mag-compute kayo, wag mo na kayo magpa-shoutout. So shoutout kay Yani Marquez watching from Las Piñas SDO Las Piñas. Magaling yan si Sir sa math eh. Diyan ako nagpapaturo kapag kanyang mga computation. Okay. So let us wait for our students to answer. Kindly type in this in your calculator, negative 635.6 kilojoule. Actually, sinerch ko po ang pronunciation niyan, kilojoule, kasi nasanay ako dati kilojoule. Pero when I search yung Google kung paano pinopronounce yung KJ, it's kilojoule. Tapos yung J, joule. Okay, wala pang nagta-type in ng answer from our students. Okay, anong answer nyo? Negative 635.6 plus negative 393.5 minus 1,206.9. This was our topic when in our week 5. Okay, so may nakita na ako. Sabi ni Kunyap, Alisto, 177.8. Sabi din ni Queenie, Diana Rose Zalun. Sabi din ni Ella Tapis, 177.8. Ni Eliza, ni Gladil, ito si Gladil, lagyan natin, si Rob, si Renz, si Trisha, si Arnold, Yasmin, Ian, Dre, Cyrus, Dayan, Gladys, Nodi, Romar, Eden, Daniel, basahin ko pa yung mga nag-effort, ni Dayan, ni Kimberly, ni Trisha, ni Ruthlyn, Sunshine, Sabina, Irish, Raven, Ruthlyn, Charlie Main, Sonny, Sanadan Jr., Jenny, Jefferson, Sasha, Trisha, Gian, Ruthlyn, Jeriel, Layan, Binoy, Dre, Roel, Edward, Ruthlyn, Happy, Leia, Marife, Kianu, Dayan, Divine, Kimberly, Trisha, Irish, Wong, Wyatt, Mike, Robert, Shaira, Haifa, Divine, Ferdinand, Roel, Edward, Ruthlyn. So ang sagot niya ay 177.8. Let us check. Sabi din ni Lara, ni Eden, ni Gina Cell. Okay, sabi ni Gina Cell, 177.8. Okay, you got it correctly. So yan yung enthalpy. Pero kailangan din natin yung entropy. So ito na yung ating entropy. Paki-ready na ulit yung inyong mga calculator. So bibigay ko na rin yung data for entropy. So ang entropy ni CaO ay 39.8 joule per Kelvin mole. I would just like to correct. Parang nung na-review ko yung video, nasabi ko kilomole, which should be joule per Kelvin mole. Okay, 39.8 joule per Kelvin mole plus 213.6 joule per Kelvin mole minus 92.9 joule per Kelvin mole. Okay. So, let us wait for our students to answer. Yan po ang dalawang entity na kailangan natin for us to get the value of Gibbs free energy. So, the enthalpy and the entropy. Okay, let us wait for our students. Sabi ni Roel, 160.5, ni Eliza, 160.5, na Faisa. Ni Daniel, ni Shania, ni Nodi, ni Lara, ni Sonny, ni Charlie May, ni Althea, ni Irish. Wala, wait lang. Ni Kianu, ni Ruthly, ni Eden, ni Romar, ni Gladys, Ian, Shaira, Layan, Divine, Divine, nakulangan lang ng 1. Ni Edward Baluarte, ni Happy Dinulong Cyrus, Jeriel Rob Siblagan, Gladil Kuyo, Lara Sadagan, Ella May Tapis, Leia, Pauline, Robert, Yasmin, Cyrus, Sabina, Raven, Gian, Jefferson, Clyde, Ferdinand, Queenie, Sasha, Eddie Tangonan, very familiar to, nag-participate na to last time. Jane, Balangge, Trisha, Konyap, Queenie, Eden, si Sherenet Bongabong from watching via YouTube, Ruth Lynn, Renz, Robert, Lara, Divine League, Jelay, Nodi, Rosa, Jaya, Dry, Lara, Haifa, Ruth Lynn, Yasmin, Robert, Pauline, thank you for participating, very active in this afternoon. Si Sunshine Guevara, Dayan, Jelay, Jan Ray, Marife, Chris, Trisha. Okay, let's see if you got it correctly. Okay, 160.5, sabi din ni Dayan. 160.5 joule per Kelvin mole. Ibig sabihin na yan, natutunan nyo ng compute yung enthalpy at saka yung entropy, and now that is important for us to compute for the Gibbs free energy. Ang formula for the Gibbs free energy is delta G is equal to delta H minus the temperature times the entropy. So sabi natin, ang ating delta H na compute base sa inyong computation ay 177.8 kilojoule per mole minus 298. Saan ko nakuha itong 298? Yung temperature kanina, 25 degrees Celsius, we converted that to Kelvin. Okay? Times our entropy ayan, kaya ang sagot niya dyan sa chat box ay 160.5. That is our entropy, change in entropy. Pero kung mapapansin nyo, this is in kilojoule. Hindi natin pwedeng i-minus ito. This is joule per Kelvin mole. Ito naman ay kilojoule per mole. Hindi natin siya pwedeng i-minus. They are not comparable with one another kasi magkaiba sila ng unit. Hindi natin siya pwedeng ma-minus. So dahil hindi natin siya pwedeng ma-minus, we have to convert this joule per Kelvin mole para maging kilojoule na siya. So, para magawa natin yon, so we will multiply this side sa conversion factor na in 1 kilojoule, merong 1,000 joule. So, i-cancel natin ang the same unit, cancel ang joule, cancel din ang Kelvin, ang matitirang unit ay kilojoule per mole. So, parehas na sila ngayon ng unit. Pwede na natin silang i-subtract with one another. Okay? So, kindly solve for delta G. Okay, so, ayan, watching from TLC. Sonny Sanadan Jr., TLC. Robert Padzing, so convert daw. So, ayan. So, solve for delta G. Ngayon, parehas na sila ng unit, kilojoule per mole. Okay, let us wait for our students to answer. Okay, may sagot na dito. Sabi ni Roel Engreso, 129.97. Sabi ni Sony, 129.97. Okay, so ni Haifa, 129.97. Let us check. Let us wait for our students to answer. Okay, so 129.97, sabi ni Daniel, ni Queenie, ni Keanu, ni Dry, Jefferson, Gian, Ella May Tapis, Dry, ay Queenie, Daniel, Eddie, Sunshine, Shanaya, Princess, Lapitan, Renz, Eden, Charlemagne, Konyap, Dayan, Althea, Romar, Happy, Jane, Ruthlyn, Nodi, Gladys, Yasmin, Ruthlyn, Gladil, Lig, Ednok, Divine, Haifa, Samad, Abdul Samad, Robert Padsing. Okay, so sabi nila 129.97 ni Kimberly, Lara, Robert, Trisha, Chris, Lara, Ian. Okay. So let us check if your answer is correct. Okay, 130. Na-round off lang dito sa aking sagot. So dito 130 kilojoule per mole. So let us analyze the condition on the spontaneity in terms of delta G. Since delta G, yung na-compute nyo dito ay positive, the reaction, what do you think is the reaction? Sabi sa condition. Kapag, sabi kanina, di ba, kapag delta G is positive or greater than 0, the reaction is, sulat ko parang, okay, non-spontaneous. Okay, non-spontaneous. Ulitin ko, since the delta G is positive, ina-analyze na natin yung result. Ang delta G na lumabas ay positive or more than 0. The delta G is positive, therefore the reaction is non-spontaneous. The reaction is, ang ibig sabihin ng non-spontaneous, the reaction is in the opposite direction. Opposite direction. Or it can be, we can say it's in backward reaction. Pabalik siya, backward reaction. Okay? Non-spontaneous siya forward, spontaneous siya on the opposite direction, backward reaction. Okay? This happens when the condition of the system is at lower temperature. Let us remember na ang temperature natin dito ay 298 Kelvin. 25 degrees Celsius. Mababa ang kanyang temperature. So at lower temperature, it is expected that the delta G is positive. Okay? Delta G is positive at lower temperature. Let us try that naman. Let us solve delta G of the same problem, but this time with temperature of 840 degrees Celsius. Okay, so I will be providing again the data. Delta G is equal to the delta and change in enthalpy and the temperature and change in entropy. So 177.8, kindly ready your calculator. 177.8 kilojoule per mole minus this is converted. 840 plus 273 that is equal to 1,113 Kelvin. So, na-convert na siya. Times 160.5 joule per Kelvin mole. And again, magkaiba sila ng unit. So, kailangan nating i-convert yung joule sa kilojoule. Tapos ayan, ika-cancel natin si Kelvin. So kindly type in this in your calculator while I cancel all the same unit. So dito, joule cancel. And then yung Kelvin, pwede natin i-cancel. Now we have the same unit, kilojoule per mole. Okay, let us wait for our students to finish computing this problem. This time at a higher temperature, 840 degrees Celsius. Okay, ano ang nakuha nating sagot, mga students? Sabi ni Divine Faith Tumbali, ni Roel, sabi ni Divine 0.84. Okay? Negative 0.84, sorry. Sabi ni Roel 0.8365, ni Yasmin 0.84, ni Renz 0.84, ganun din sabi ni Rob, ni Happy, ni Queenie, ni Nodi, ay ika lang nagsabi-sabay, Nodi, Shania, Robert, Dray, Althea, gusto ko basahin lahat kasi nag-effort kayo. Dayan, Shaira, Ruthlyn, Shania, Nodi, Robert, Drydrain, Dayan, Shaira, Ruthlyn, Lawrence, Eden, Ian, Sunshine, John Bryce, Althea, wait na, wala. Ang bilis pumasok ng mga messages. Saan na ba yan? John Bryce, Althea, Romar, Daniel, Keanu, Cyrus, Haifa, na Abdul Samad, na Lara, Ruthlyn, Sunshine, Sherenet, Trisha, Charlemagne, Diane, Princess Joy, Sasha, Gladys, Shaira, Junimi, Gamongan, Junimi, Gamongan, Alaisa, Gladil, Lara, Jelay, Eddie, Zai, Byron, John Ray, Nelly, Ferdinand, Sony, Fame. Okay, pagod ako kasi nag-effort kayo. Raven, Lara, Rob, nag-participate na to eh. Paano nga ulit pronunciation yan? Magnual, Eden, Christine, Jeriel, Clyde, Jenny, Marife, Eden, Raven, Denzel, Kimberly, Konyap, Sunshine. O, ayan. The answer is negative 0.8 kilojoule per mole. So, let us analyze the condition. So, sabi dito, at 840 degrees Celsius, ang naging delta G natin ay negative 0.8. So, sinabi dito, kapag, sabi dun sa condition kanina, if the delta G is negative, the reaction is spontaneous. So, isulat natin dito. Yung kanina, positive, non-spontaneous. This one naman, spontaneous in the forward reaction. Kung kanina, backward yon, so ito, forward reaction. So, if the delta G, again, is negative, so spontaneous in the forward reaction. So, dito natin binasa yan. Sabi natin, kapag negative, spontaneous in the forward reaction. Di ba negative yung kanina? Ayan, negative. So, spontaneous siya. Kapag naman greater than 0, katulad ng kanina 130, the reaction is non-spontaneous or backward reaction yan in the opposite direction. Pero kapag ang delta G ay equal to 0, the system is at equilibrium. Ibig sabihin, there is no net change. So yan naman ang susunod nating most essential learning competency. Explain chemical equilibrium in terms of the reaction rates of the forward and reverse reaction. So most of the reactions we've looked so far have been in this form. So the coefficient of A reacts with the coefficient of substance A reacts with coefficient of substance B, producing coefficient of substance C and coefficient of substance D. So yan yung common nating na-encounter sa chemical equation or chemical reaction. But in chemical equilibrium, a condition in the course of a reversible chemical reaction in which no net change, the delta G is 0, in the amounts of reactants and products occurs. It is necessary that we understand that the chemical equilibrium is in reversible reaction. Because, ayan, chemical reaction like this. So, merong ang symbol na hindi lang forward, kundi forward and backward reaction. It is important that we understand that chemical equilibrium is in reversible reaction because Le Chatelier principle ang magpe-predict. So the Le Chatelier principle will help us predict the shift in the direction of the reaction. So sabi dito, state that the Le Chatelier's principle and apply it qualitatively to describe the effect of changes in pressure, concentration, and temperature on a system at equilibrium. Ito po yung ating ngatlong most essential learning competency. Okay, the Le Chatelier's principle states that when factors that influence an equilibrium are altered, so ano yung mga factors na yon? We have the concentration, we have the pressure, and the temperature. So, meron din yung catalyst and inert gas. Pero dun sa most essential learning competency natin, ang gustong nating i-focus ay yung concentration, pressure, at temperature. Okay, the equilibrium will shift to a new position. That tends to minimize those changes. I searched the definition from Khan Academy, the definition of Le Chatelier. The Le Chatelier's principle states that when a system experiences a disturbance, ano nga yung mga disturbance na yon? Concentration, pressure, temperature. So yan yung nadi-disturb sa chemical reaction. When a system experiences a disturbance, it will respond to restore new equilibrium state. So, yung chemical reaction ay mag-shift ng direction forward or backward para ma-attain yung equilibrium. So, let us focus on concentration first. If there is a change in concentration, okay? If there is a change in concentration, if additional reactant is added to a system, the equilibrium will shift to the right towards the product. More reactants lead to formation of more product. So halimbawa ito, we have the equation of hydrogen gas, 2 moles of hydrogen gas reacts with oxygen gas with reversible reaction with 2 moles of water in a gas form. So dito, hindi siya in a liquid form, gas form siya para maging reversible reaction siya. So if additional reactant is added to a system, kung nagkaroon ng increase in the hydrogen o kaya increase in the oxygen, the equilibrium will shift to the right or towards the product. Okay? Kapag sa reactant kayo nagdagdag, the direction of the reaction will shift towards the product. Kasi sa reactant kayo nagdagdag, more reactants lead to the formation of more product. Siyempre, marami kayong reactant, edi marami ring magiging product. So para maging in equilibrium siya, it will go in forward reaction. Okay, sa mga modules and worksheets nyo na sasagutan na hawak nyo ngayon, more likely ang tanong dyan is, you will identify the direction of the shifting in the reaction. So will it shift forward or shift backward? Okay, next. If the concentration of the product will be reduced or decreased, the equilibrium will also shift to the right. So same equation tayo. Kung ni-reduce ko ito, kung kinontian natin, kung nakontian naman ang product, syempre, dahil kumonti yan, the formation of products is needed to achieve equilibrium. Kung kumonti ito, syempre, magpo-forward reaction pa rin yan. Will shift to the right pa rin, towards the product pa rin. Kasi kinontian nyo ito. Pero kapag ito ay in-increase nyo, definitely, it will shift to the reactant side. Okay? So kung nasan yung stress, kung nasan yung disturbance, kung nag-increase kayo sa reactant side, the direction will be towards the product. Pero kung nag-increase kayo sa product side, the direction of the reaction will go towards the reactant. Okay, next. If there is a change naman in product, okay, so sa product tayo nagdagdag, katulad yan, the equilibrium will shift to the reaction side. So kung tinaasan natin ang ating product, syempre dahil there is an increase in our product, the shift will be towards the reactant side. Nag-increase kasi ang ating product, so syempre it will favor on the backward, on the opposite direction, towards the reactant side. Okay? So kanina nag-increase tayo sa reactant, nag-favor sa forward reaction. Ngayon naman nag-increase tayo sa product side, it will favor backward reaction. Next, if there is a change naman in the reactant, if reactants will be removed from a system, same equation tayo. If reactants will be removed from a system, equilibrium will also shift to the left. Dahil nag-remove kayo dito, nagbawas kayo sa reactant side, the reaction will go to the left or towards the reaction. Siyempre, maraming nasa product, so magba-backward reaction na yan. Next, pressure. Kung kanina puro concentration yung binabanggit ko, this time naman is an increase in pressure. In changing the pressure, an increase in pressure will cause the reaction to go toward the direction that favors the formation of a smaller volume. So example, itong equation na to, tingnan natin yung kanilang states. Pare-parehas naman silang gas. So walang problema, lahat sila ay maapektuhan niyang pressure. Pag binago ang pressure, lahat gas. So syempre, pag in-increase natin yung pressure, liliit yung volume, di ba? Yung gano'n yung sa may gas loss din. So pag in-increase ang pressure, liliit ang volume. So dun tayo sa moles. Dun tayo titingin sa moles. Kaso, parehas nga silang gas. Ang susunod na titingnan natin ay the coefficient. Sa reactant side, ilan ang total ng moles? So ito ay 1, ito ay 1 din. So 1 plus 1, ang nasa reactant side ay 2, ang nasa product side ay 2 din. So in this case, pressure will have no effect. Una, pare-parehas silang merong, ayan, pare-parehas silang nakagas. Gas sa reactant, gas sa product. Ang susunod na titingnan natin ay yung number of moles. Ang number of moles niyan ay total ng 2, equal lang sila. So therefore, pressure will have no effect in this chemical reaction. Next, CaCO3, solid calcium carbonate, has a reversible reaction with solid calcium oxide and carbon dioxide gas. Okay, ito yung tungkol naman sa pressure. The products take up more volume than the reactant because one of the products is gas. So, kung titingnan niyo yung state niya, sa reactant ay solid, sa product may solid pero may gas. So the products take up more volume kasi gas nga yung CO2, di ba? So it takes up more volume than the reactant. Dahil nga gas si carbon dioxide. Increasing the pressure puts a stress on the product side. Kapag yung sa product side ay in-increase natin yung pressure, so medyo maapektuhan talaga si carbon dioxide, to minimize the stress pag na-increase yung pressure, definitely, ngayon ang tanong ko sa inyo, predict the direction of the shift in the equilibrium. Sa tingin nyo, forward ba siya or backward reaction? So, maghihintay ako ng sagot. Ito lang yung tanong ko sa forward and backward reaction. Will it go forward or backward reaction knowing that only the product side has the gas substance? Kapag na-increase ang pressure, at what direction do you think will it shift for it to have equilibrium? So hintay tayo. Ang sagot nyo lang, is it forward or backward? Forward reaction or backward reaction? Case, hello, Shirel Garpen. Sabi din ni Eden, siya pala si Ginacel. Si Ginacel yung nag-answer. Okay, ano po ang sa tingin nyo? To minimize the stress, knowing that carbon dioxide is on the product side in gas form, will it shift forward or backward? Okay, students? Predict the direction of the shift. Product side is in gas form. Okay, you may try to guess. Sabi ni Roel, Veridiano, Nikiano, backward reaction daw. Sabi ni Pauline Payaki, backward. Nag-recite din to last time si Pauline. Ni Nodi, backward. Ni Karen, backward. Ni Renz, backward. Okay? So, dahil sa pag-take time nyo, na-realize nyo na backward siya. Ni Daniel, ni Jefferson, ni Althea, ni Ian, ni Happy, ni Cyrus, ni Kane, ni Ruthly, ni Eddie, Nelly, Dry, Rob, shift backward daw. Romar, Gladil, Denzel, Robert, Renz, Karen, Dayan, Haifa, Lara, Charlie May, Ruthlyn, Nodi, Pauline, ayan na. Okay. Ni Junimi, Lara, Abdul, Samad, Chris, Raven, Lailan, Sally, Queenie, Jenny, Shania, Eden, Ruthlyn, Lara. And also sabi ni Sonny, Kimberly, Jerrell, Pisconath, Lara, okay, Christy, Dayan, Lara. Ni Jerrell, ni Pisco, ni Lara, ni Eden, ni Junini. Okay, sabi nyo backward. Okay, let us check. Okay, that is correct. Backward siya. Siyempre, dahil sa product side lang ang maapektuhan ng pressure kasi yun lang ang may gas, pag na-compress siya, it will favor the backward reaction. So, very good kayo. Okay, let us now proceed to the change in temperature. Okay, sa changes in temperature, if the reaction is endothermic, so na-discuss ko na rin sa inyo yung endothermic and exothermic. So this is just a recall. Pero kailangan natin yung concept ng endothermic and exothermic para ma-identify natin yung effect ng temperature sa chemical equilibrium. If the reaction is endothermic, heat is being absorbed by the system. And the value of the delta H is positive. Therefore, we can consider heat as one of the reactants. So, nasa reactant side. Hindi siya reactant, pero nasa side siya ng reactant. yun ay endothermic. Next, if the reaction is exothermic, heat is released. Thus, heat is a product and the value of delta H is negative. So again, released, tapos nasa product side ang heat. Siyempre, dahil na-release yung heat, dapat nasa product side siya. Ito naman, ang heat ay na-absorb, dapat ang heat ay nasa reactant side. Okay? So let us have an example. This is an endothermic. So sabi dito, pag nasa reactant, that is endothermic. Ang heat ay nasa reactant. Increasing the temperature on an endothermic reaction will shift the equilibrium to the right. Dahil ang reactant ay ang heat ay nasa reactant side, kapag in-increase nyo ang heat, syempre, the shift will go to the right. Okay? Then in-increase nyo ang heat, tumaas ang heat. Okay? Mag-favor yan in a forward reaction or shift to the product side. Next, kapag dinecrease nyo ang heat on an endothermic reaction, binawasan nyo ang heat dito, ibig sabihin, binaba natin ang temperature. Kapag binaba nyo ang temperature, it will shift the equilibrium to the left. So, magiging backward reaction siya. So, dito, backward. And this one naman is forward reaction. Okay? So kapag nagsagot kayo ng worksheet nyo, you may revisit this video para mag-guide kayo sa pag-a-answer kapag sa temperature, pressure, at saka concentration. Next, if the temperature is increased in an exothermic, kung ang exothermic ay nasa product side ng heat, so kapag in-increase nyo ito, syempre the direction of the reaction will shift to the left. Okay, so it will be in backward reaction. Next, if the temperature is decreased, the equilibrium will shift to the right. So kapag decrease ang heat, okay, bumaba ang temperature, okay, it will shift to the right. The equilibrium will shift to the right. Dahil binaba nyo ang temperature dito, it will shift to the right. Forward reaction na yon. Okay? So, this is just an additional, pero ito talaga ay kasama din sa ETUlay, sa addition of a catalyst. Pero sa most essential learning competency natin, ang gusto i-focus ay yung temperature, pressure, concentration, temperature, and pressure. But I just added this, ito sa mga college books na nakasulat din ito, addition of a catalyst. Catalysts do not have an effect on equilibrium. Pwede kayo magdagdag ng catalyst, pero hindi siya makaka-apekto sa equilibrium of the system. Pero ano ang gagawin niya? Pabibilisin niya ang chemical reaction para maging mabilis yung pag-reach ng equilibrium. Okay? Pabibilisin niya lang yung rate lang ang binabago niya. Pero yung sa chemical reaction, the equilibrium itself, hindi naman niya binabago. Okay. So, ayun po yung topic natin. So, for Gibbs free energy, again, that's topic for yung hinabol ko lang yung last week. Tapos yung sa chemical equilibrium hanggang sa ETUlay. So yan pinilit kong pagkasyahin kahit na gusto kong mag-throw ng mga questions. Pero medyo mahaba yung topic. Kaya ayan, tuloy-tuloy ako. Before kasi ang dami kong tanong sa inyo, di ba? So, pero nakapag-participate pa rin kayo, nakapag-recite pa rin kayo. Thank you sa inyo na weekly nandito uma-attend. You are really helping yourself. You educate yourself. You are doing something for you to improve. So, salamat sa inyong mga magulang, salamat sa inyong mga guro for guiding you, at sama-sama nating itulay ang ating pag-aaral even in the midst of pandemic. So, maraming salamat. Magsama-sama po ulit tayo sa susunod na Monday, 5:20 to 6 for week 3 of quarter 4. Maraming salamat po sa inyong pag-attend. God bless everyone. To God be the glory.
Sigurado ako na marami ka na namang natutuhan sa ating ETUlay tutorial session ngayong araw. Tandaan, ito ay hindi lamang para sa ating mga mag-aaral, kundi pati rin sa ating mga minamahal na guro at mga magulang na kaagapay natin para maituloy ang pagkatuto sa kabila ng nararanasang pandemya. Patuloy ding sumubaybay sa DepEd TV para sa mga araling ginawang video episodes. Mapapanood ito mula Lunes hanggang Sabado, alas 7 ng umaga hanggang alas 7 ng gabi sa inyong mga telebisyon. Abangan bukas mula 1:00 ng tanghali ang iba pang aralin sa ating ETUlay free online tutorial session sa English. I-like and subscribe at manatiling nakasubaybay sa ating ETUlay tutorial session sa DepEd Edtech Unit FB page at Educational Technology Unit channel sa YouTube at sa DepEd Tayo at DepEd Philippines social media accounts. Paalam!